Quiet on the set. Why is it that one phase is heating up like that and the other isn't? Cut it off, yeah? What? Well, we need to cut it off. Something's buzzing really loudly, like right in my face, damn. Hello, my name is Dmitry. Welcome to the DPLABS channel. Sorry for the long absence, as there have been quite a lot of changes and quite a significant amount of work. In today's video, we will be focusing on our electric motor, the gearbox, and in general, what's currently happening with our ATV project. And of course, this is our engine testing stand. So let's get started. What do we see here? We see our 15 kilowatt electric motor, and this is its latest version, already paired with the gearbox. The gearbox, as you may recall, features a differential lock. Inside, there is a limited slip differential. Everything is carefully assembled and it all works smoothly. We have created a dedicated test stand for it that accurately measures torque. And we can measure power, efficiency, and also conduct, let's say, long-term endurance tests at nominal and increased power levels and so on. Because in engine building, let's just say, you can't do without a test stand. Now we'll show you, okay? The project for the ATV is also steadily moving forward. Here is its sturdy frame, which is even perfectly straight. Very soon you will see how it gradually starts to take shape. A truly great battery has been carefully prepared for it. 102 volts, lithium NMC LG also. Vanya, what's the capacity on it? Almost 15 kilowatt hours. Yes, 15 kilowatt hours, really great. Please pay attention to how the terminals are carefully sealed. We welded fittings for the hoses. A silicone hose will simply be attached here, which will go upward. It will also serve as a breather, and everything will be sealed, so there's no hassle. Excuse me, is this for cooling? Yes, this is for cooling. The battery has cooling. Since I had a lot of other work, I didn't take part in assembling the battery. By the way, I wanted to ask, what do we have inside there? Are these fins of ours for cooling, or how is it done? No, it's just a tube. A tube. Well, I think that should be enough. The loads here aren't that extreme. But it's pretty hefty, we should weigh it later. Do you know how much it weighs? Well, probably about 30 kilograms. Yeah. Alright, maybe let's say about 32 kilograms or so. So, what else do we have here that's good? Gentlemen, I apologize. So, for now, we're not testing on our own motor, but we have a motor from Golden Motors. Its nominal power is 5 kilowatts. So, what do we have here? This is the kind of test stand that we currently have. We were thinking about how to do it and wanted to use a truck retarder as a load, but it was all a hassle to set up, so we eventually decided to do it this way. We took a motor from a Nissan Leaf, and it's running in generator mode. And as a load, we thought, and Ivan came up with the idea to use these welding rheostats. Each one is rated for 500 amps. There are a lot of steps here, so you can select the required power. They're reliable, with heating elements inside. And we connected them in a star configuration, so you have to lug them around. They weigh up to 40 kilograms, maybe even more. Finally, we'll set up the cooling. These are really cool fans we bought from V's Instrumenti, and their rated output is just right. 515 amps is more than enough for us, but what does that actually mean? The test bench does have a certain limit on the cooling system. Here, the engine is connected through what are known as Bazovsky couplings. And right here, we have a pretty decent and reliable torque sensor, which we purchased on Ring. If I remember correctly, it's a DD50. Seems like it's rated for 100 Newton meters. Yeah. But there are also versions for 300 and 500. It's a great thing, because similar ones, well, I can't vouch for its accuracy, but for our purposes, it's more than enough. It also has a digital output, so you can send data to a computer. And it shows the RPM and torque, and actually it also displays the power. So basically that's how it works for us. As far as I understand, torque multiplied by angular velocity gives you the power. So you can actually measure real parameters. There's a small display here. By the way, we've just connected it to the titanium card, so we don't have to assemble a new battery, because that battery is 102 volts. And this motor is 20S. Otherwise, the controller will throw an error. We'll be measuring the power consumption. There's a current shunt installed in the card. But we also need to take into account the efficiency of the controller itself. I mean, not the controller, but its driver. The inverter, what is it, running on MOSFETs. But I think its efficiency is about 92 to 95%, so we'll add about 5 to 7% to account for losses. And here we have a high-tech gas pedal with fine adjustment. That's how it's set up. All right, everything has started spinning now. Gentlemen, please note that the torque is currently negative. This indicates that the rotation is in the wrong direction. Well, anyway, it's showing 11.9 Newton meters and a power of 22 watts. Right now it's at 268 RPM. So how does it actually work? The motor is operating in generator mode, producing three-phase current. These rheostats are connected in a star configuration, and inside them are heating elements. So basically, all the energy is converted into heat. So what do we have here? Well, it looks like we have a radiator from a VAZ vehicle, and right over here is a heater pump. This particular component is for the heater, correct? Seems like it's for the heater. Well, everything is working, everything's fine. Now we're going to run it on a Golden motor just to demonstrate how it works. Right away, right now, by the way, we'll find out what its actual efficiency is at nominal power. Well, let's rev it up. So gentlemen, since our rheostats are new, they're burning in a little. It's getting warm, nice and warm. As you can see, we've turned it on. So gentlemen, we've now roughly and carefully adjusted the rheostats, making sure that the power output is much closer to the nominal value. Right now, at this very moment, it's reading 4.7 kilowatts, which is approximately 10 to 11 Newton meters at 4,000 RPM. It's jumping because it's biphasing. Yeah. The RPMs are fluctuating a bit because we had to... One phase is disconnected, and here is the rheostat in this position. So now, what about the power consumption specifically? Here we have this particular kind of meter. So it's currently consuming 5.5 kilowatts and producing 5 right now. So the overall system efficiency is about 90%, and the motors are at 92 to 93%. Well, that's what Golden Motors claimed at nominal. So, Vanya, try to crank it up a bit more. Shall we turn on another phase? We can, yeah. I've tried, you can even do 2 at once. So, should I turn it on? Alright, 8.8 kilowatts. 20 kilonewton meter. Look, it's glowing red hot. Don't bring it over. Should we turn it off? What will happen to it? I don't know. It's fine. Well, it's heated up, so what? What, are you feeling sorry for it or something? So at 8 kilowatts, what do we have at 8 kilowatts here? 10, and here its efficiency started to drop. Cut it off. This one. And here, yeah. Oh, 13 kilowatts. Well, it's not heating up too much. So gentlemen, the experiment was a failure. Everyone immediately got sad. In short, we've determined that the Bazovskaya Bofta isn't suitable for this experiment. The maximum was 13 kilowatts there. It got a little messed up. It's kind of scary. There was a casing here. Ivan, we need to come up with something. Why did this happen? Strange, it's strange. So this engine was only running at 13 kilowatts, but we need to test something more powerful. We'll come up with something. Maybe use a different flexible coupling, not the VAZ one. Is that it? Seriously? Oh, and it bent these, right? Yeah. Did you make this from ST3? Or was this the original crap? No, it was from what was on the VAZ. It's substation steel. Substation steel, but you need cherry quality steel. Yeah. Right. There were about 5,000 revolutions in total. But I mean, on the drive shaft, the VAZ doesn't have 5,000 revolutions. Anyway, the guys will come up with something and we'll continue. The main thing is the overall concept works. Everything's fine. I need to use rheostats from miners. I have some lying around somewhere. Install fans so at least they blow the smell away. And so nothing heats up to red hot. These are good, I recommend them. You can test batteries with them. It's a pretty inexpensive electronic load, so it's quite suitable. That's it. By the way, for long-term testing, we need to find a powerful power supply somewhere or put together a hellish battery. You know, for these endurance tests. That's it. And basically some kind of... How much voltage do we need there? 102 volts, some kind of crazy transformer. And a brutal bridge rectifier. And capacitors, I have those. Well, we'll figure something out anyway. That's not a problem. I also wanted to mention the titanium cabin. For now, we've been using it as a power source. It's been in use all this time. There were a few minor issues, but the main issue was that our brake calipers started leaking. Why is that? Yeah, exactly. The calipers started leaking. They make such crap, I don't even know how far it went. Other than that, it's been put through its paces, used heavily even in winter. Of course, we leave it charging overnight to make sure the battery is fine. And for all those naysayers who said our swing arm would fall apart, everything's fine with the swing arm. We've loaded it up with about 500 to 600 kilograms of all sorts of junk, and it's still holding up. You can see here, clear signs of heavy use. The battery lasts for a day, maybe even longer, from zero. We never managed to fully drain it. To be honest with you, the wheel motor. But it's a bad idea if you just use it like that, etc. But I think it'll last a long time. Over there, of course, that's how they're made. These are G motors made by them. Vanya took one apart. He said the wires inside are a mess, like they were laid out backwards. Honestly, it feels like the Chinese assembled it with their feet, but somehow it all works. So basically, it's like used. It's got a lot of mileage. The body is ours, and it's actually still in good shape. Nothing's really banged up. He uses the inverter whenever he needs to weld something. It has a built-in 5 kilowatt inverter. He actually found one right on AliExpress for just $20, which is quite affordable. This inverter works perfectly fine up to 90 volts, and it does the job well. So yeah, overall it's a really good car. What's a demo? And the operator, the one who uses it, is asking to have the seat heating activated. Well, we need to figure this out somehow. We need to install a temperature sensor or controller, otherwise he'll either burn his backside or the whole cabin. That's how it is, gentlemen. Well, what can I say? We'll get the test stand in order soon, right, Vanya? We'll be back to you in the near future. So, gentlemen, I hope you enjoyed it. Subscribe to the channel, give us a like. See you soon, bye.